You may remember, I have a photo here of one of the big community meetings that the Paradise Irrigation District held early on. There was a lot of concern due to the issue of benzene contamination popping up after the campfire. And our group, which you can see, it includes the Public Health Institute, which is in Oakland, UCSF, University of California, San Francisco, UC Davis, and Tracking California, which is a project of the Public Health Institute. And we all partnered together and we were able to get an emergency grant from the National Institute of Environmental Health Sciences to do a project testing at people's taps for free to try to figure out what was going on really in the home after the campfire. And unfortunately, given the delays of getting funded, we got the funding in September of 2019, and we started our testing in October of 2019. But that was still quite a while after the fire, as Emily noted in her comments. And the areas, this shows a burn map. And it shows that Paradise Irrigation District, and then the Lime Saddle, Paradise Pines, Magalia, Buzztail districts of the Del Oro system were the main areas that were affected. And then some areas like Concow that were really where people mostly had private wells. So that was the focus of this study. And the questions that we were asking is, benzene, it was popping up in the water system. Our question was, is it also ending up in people's tap water in the homes? Where was it coming from? And were there other contaminants that might not yet have been identified that were also in the water? And so we took a look at the data from the Paradise Irrigation District. This slide shows our analysis of that information, and actually it goes all the way till May 2020 because we updated it to include pretty much all of the results. One of the interesting things is that when you look at where the detections were, and this is just PID, it's not Del Oro, we haven't actually done that analysis yet. But it does show a big difference in terms of where the benzene was found. And I have highlighted in yellow, 21% of service lines to destroyed homes contain benzene. And the contamination levels went up pretty high, a maximum of about 1,000 times higher than the legally allowable level. So 21%, that's about 1 in every 5 service lines to destroyed homes. But in comparison, they tested the service lines to standing homes, and only 1% of those in all the months that they tested actually turned out to have benzene contamination. And the maximum still went up pretty high, but it was not nearly as high as in the dead end service lines. The main lines also were relatively low. Also points out their appurtenances. Those are things like fire hydrants, for example, that they also tested. So that gave us some hints that the worst were going to be to destroyed homes, but they did find them in service lines to standing homes. The other pattern that we noticed when we analyzed the data from PID was that almost all the detections were in the first 6 months after the fire, and then they really faded out after that. And that was from a combination of things. It was a combination of the fact that PID was out there replacing lines. Emily pointed that out, which is important. The other is that the water was getting flushed through both intentionally by the water company and also just by the fact that people were using it. So it was ending up sort of flushing out the pipes in general. And so you can see here the dark gray and the light gray are the detections above and below the legally allowable level. And you can see that those show up quite a bit in the first 6 months and then kind of taper off, even though they continued to do a lot of testing. So that's another good clue that levels were going down. By the time we actually got out there in October of 2019, there were not a lot of detections in the water system, which may be partly why we didn't find a lot. So here's what we did. One of the members of our sampling team standing at somebody's sink, collecting a sample. We used a standard EPA testing method that tests for about 100 different volatile organic compounds, including benzene. So we were looking for far more than just the one chemical. 109 homes in the Paradise Irrigation District, 27 in Del Oro, plus quite a number of blanks, just to make sure that the labs were not introducing contaminants. We went back in November and collected just a few additional tests in homes where we found something in the first round. And in that, mostly in that second round, we collected samples in 10 homes for what's called non-targeted analysis. So if you got one of those tests done, you'll know that it was a big glass jug that was sort of amber colored that one of the researchers from UC Davis filled all the way up to the top and hauled off to their lab. And they tested for thousands of chemicals in those samples. For those tests, we selected the homes that we thought were potentially the worst cases. The 2 in Paradise that had traces of benzene, the homes that had methylene chloride or tetrahydrofuran in the October testing, and I'll get to that. And some homes that had been just totally vacant since the fire. And so we collected those. And as you can see from this map of the Paradise area, we tested at homes all throughout. So we got a pretty good scatter of homes in all different parts of all of these water systems. And that was good. We were a little worried we'd only get samples in certain neighborhoods, but that was not the case. All the red dots scattered all over these maps show where the tests were done. So let's get to which volatile organic compounds did we find? Well, this is a big chart and it shows all the chemicals we did find. Out of 100, we only found a subset of about a dozen. And so I'm going to circle here in green these 5. And so these are all disinfection byproducts. And in fact, the top 4 add up to the bottom one. They're all components of the total trihalomethanes. And if you were in the PID service area, you probably had those in your water unless you had a Culligan system or some other kind of water filtration system. But the folks in the Del Oro service area, especially the ones like up in Paradise Pines that are on groundwater, did not have much or any of these disinfection byproducts. So that's an advantage of groundwater. These were in the water before the fire. They are not fire related. But on the other hand, they can have health effects. So it's important to know about them. The levels were all under the regulatory maximum allowable level, but some of them were getting pretty close. So they were a little higher than I would ideally like to see. Now just circled in red here is benzene. And we found that in 1% of our samples, specifically in 2 homes at really low levels that were about 1/10 of the regulatory allowable level. or so-called maximum contaminant level. And so, not really a health concern, but still a worry, because we knew that the benzene was, if anything, trending downward. And if we detected it at all, that was worrisome. So that, and it was completely consistent with what PID was finding actually in the service lines to the standing homes, about 1%. Then I wanted to point here to our biggest surprise, which is methylene chloride. That popped up in 19% of the homes that we tested, and almost all of those homes were in the PID service area, not the Del Oro service area. I think all of them were in the PID service area. And even more distressing than the fact that that popped up in 19% of homes was the fact that the levels were up to about double the maximum contaminant level, or the regulatory limit or regulatory level. So that was a bit high. Methylene chloride is just like, like benzene, it's also a carcinogen. So it's not something you'd like to see in the water system, but we didn't expect to find it this commonly. And then the last thing I wanted to point out was this, which is tetrahydrofuran popped up. It only popped up in 3 samples, all in the PID service area, but the levels were quite high, and there's no regulatory limit specifically set for this chemical, but still there are guideline values in a couple of other states, Michigan, New Hampshire. Some of these levels were above those guidelines. So those were the main things we found. The others on this list are less important, I think, because we only found them in 1 or 2 samples and the levels were very, very low. So they're less, I think, less important findings. So let's talk a little bit about some of the things that we found. And I want to jump quickly right away to methylene chloride, since that was in nearly 20% of the homes in PID. Why is it there? That was something we've been struggling with, trying to understand. We've been doing different analyses, and we found a number of different key associations, 5 main points. One was the longer the stagnation period of the water, the higher the methylene chloride levels tended to be. And that's what the chart on the right shows. So if the water was only stagnant for 12 hours, which was about what we were asking people to do, the methylene chloride levels on average were lower than if it was stagnant for at least 24 hours. And the homes that were most likely to have high methylene chloride levels had water stagnant for more than 72 hours. And many of these homes actually had the water stagnant for literally weeks or months. So the longer the water sits in pipes, the higher the likelihood of finding it. Issue number 2 that we found, the homes that were further from their service connection, so from their water meter, were also more likely to have methylene chloride in the water. This may be related to the stagnation problem. Another thing we found was if there was another structure, another home next door or some other building that was on the same service connection and the other building burned down, there was more likely to be methylene chloride in the water. In addition, we found a slight association with galvanized iron pipes in the home, and finally an inverse association with trihalomethanes, or disinfection byproducts. So those tended to drop in association with higher levels of methylene chloride. So we're trying to understand it all. There's a few different theories. One is that it's related to the fire. Another theory is that it's related actually to zinc in the galvanized iron pipes, converting some of these disinfection byproducts such as chloroform, into methylene chloride through a chemical reaction that gets worse the longer the water stagnates. We're not quite sure which is the case. We're still trying to figure it out. We're actually trying to set up some experiments in a laboratory to test this question. And it kind of matters, because if it's something that occurs in any home potentially that has iron pipes, that has implications for a lot of homes. So we're trying to figure if it's fire related or not. Wish I could tell you for sure right now, but it's still underway. One other thing I wanted to mention is tetrahydrofuran. I mentioned that as being high in just a small number of homes, just 3 homes. We actually figured out why that was the case. And that was because a lot of pipe repairs were going on. When PVC pipe is connected, is repaired, and they cement together different sections of pipe, they often use PVC cement, and the specific brand of PVC cement that they were using in the PID service area contained tetrahydrofuran, among other chemicals. So that was probably what we were picking up. That's an issue because it shouldn't be in people's water, and we know that there was certainly a lot of pipe repair going on. And the picture here shows somebody's meter box. They were taking out people's meters and putting in these little PVC jumper pipes and using cement to put those in place. And that was going on at the same time we were doing our sampling. So then finally, I had mentioned, almost wrapping up here, the non-targeted testing that was done at UC Davis. They found a lot of disinfection byproducts in all of those samples, including the ones we tested for, but even more that we did not test for in our original study. Now, these are all chemicals that are not really regulated, but some of them are a potential health concern and may be regulated in the future by the water systems and the State Water Board. 2 of the samples notably had quite a few different chemicals that are found in smoke, including things called polycyclic aromatic hydrocarbons, which are found in things like cigarette smoke and wildfire smoke. So those suggest that there was smoke being pulled into the pipes during the fire. And then one sample had some plasticizer chemicals that are plastic softeners called phthalates. And so those were the main things discovered on non-targeted testing. Somewhat helpful, but not totally slam dunk in terms of clarifying what's going on. And then I hope all of you received your results return packets that looked like this, with the first page showing a summary of your tap water results, and then the other pages showing specific information about volatile organic compounds and methylene chloride in drinking water. These fact sheets are also on our website, and we'll show that link and put it in the chat so that if you want it, you can look there. It's also in the letter that you will have just received by email or in the mail if you look there. And so you can always refer to those fact sheets for more information. But just to summarize the recommendations, basically, the main recommendation is that we think that it's okay at this point to drink the water in the service areas that we tested. We did not see any contamination, although we did find some in a few homes. We went back to all of those homes, we tested again, did not find, for example, the methylene chloride after the water was run and flushed. So we think that it's, we think generally the water is pretty good there. But it certainly can't hurt to use a filter. And in particular, the trihalomethanes in the PID service area were high enough to be close to the regulatory limit, and so we would recommend considering using a filter. A Culligan is maybe, maybe more than you need. It certainly can't hurt. But so I understand that you installed one of those, and that's fine, and many people did. But you could also get away with something as simple as just a countertop filter pitcher, or even a carbon filter in your refrigerator if you have a water dispenser in your refrigerator. All of those work well to remove trihalomethanes. Also, there are filters that you can attach to your water faucet, like one pictured here. So basically, a carbon filter is the least expensive option. And then, of course, you can go to all kinds of options that are more sophisticated as well. The other thing is, if your water's stagnated in the pipes for a long period of time, run it before you drink it. When you wake up in the morning, for example, it's probably a good idea to flush the toilet and maybe take a shower before you drink the water. That flushes out your pipes pretty effectively without wasting water. If you've been away for a period of time, again, you might want to flush the toilets, run a little bit of water, and then just to flush out the pipes. And then if there's repair work going on, and I understand, the Del Oro service area, it sounds like quite a bit of work's going on. You might want to flush the pipes out well, just to make sure that that there's nothing from the PVC cements that is popping up in the water supply. We are also making some recommendations around future fires, including making sure to shut off, it can be difficult to rapidly shut off sections of the water system that depressurize. Installing backflow prevention devices, I know that's happening in your area, and I think that's great. That can really be beneficial to keep contaminants from getting into the system and spreading around through the pipes. And then, of course, getting in quickly after a fire, doing rapid testing is essential. And this combination approach of flushing pipes that have low levels of contaminants and replacing pipes that have higher levels of contaminants seems to have been pretty effective. I'm not actually necessarily an advocate of replacing every section of pipe. You really need to be judicious and look and see whether it's a low level that could be addressed by flushing, or a high concentration where you just have to flush and flush to really get it out. So you might as well just replace it. It's a tough decision to know where that point is, but something that I think will, it's shown to be effective. So basically, this is our team, our water sampling team outside the Starbucks in Paradise. When we took a little break after a day of sampling, and the information about the study is on this website, trackingcalifornia.org/fire-and-water/VOCs. And this is my contact information, gina.solomon@phi.org, and my contact phone number, 415-289-9310. So those are all the ways to get more information and to get a hold of me. And that's all I have. So